important type of forces is the air resistance or liquid resistance. Now, it is a friction, okay, between the object that is moving through the air or through the liquid and the liquid particles or air particles. Because of this, we call it air resistance and liquid resistance. And because it is a friction, always the direction is opposing to the movement of the object, which means what? If I have an airplane, for example, let's imagine that this is an airplane. If this airplane is moving in this direction, so the air resistance will be in the opposite direction. And of course, if we have an object that is released from some height, and so it will drop to the ground, of course, because the movement is downward, the air resistance will be upward. So it is always in the opposite direction of movement. Same exact idea, if this object is at a certain liquid, okay, so it is now the liquid resistance, which is because of something called viscosity of the liquid, which a term that represents how much is the friction between the object and the particles in the fluids. In any ways, so this is air resistance and liquid resistance. Now these resistances always depend on two things. The first thing is the speed of the object, and this is very important, boys and girls. The relation is direct, so the higher the speed, the higher the air resistance. Okay? We will use it after a while. And the other thing is the surface area. Increasing the surface area means that the air resistance is more. And because of that, we will talk about an example after a while for the parachutist that is diving through air after jumping from an airplane, and we will talk about it very well. Now, the effect of air resistance is what? Let's see this important animation. Now, dropping an elephant and a feather from the top of a building with no air resistance makes both of them to reach the ground together. Again, now look, they will keep moving in the same rate to reach the ground together. Look. So why is that? This is because both of them are affected by the same exact gravity, which is 9.8 meters per second squared, or 9.8 newtons per kilogram. And so the same rate of acceleration, the same rate of the same gravity is affecting both of them. Both of them will reach the ground at the same exact time if there is no other forces than the weight. And this is called free fall. Now, what if there is a resistance? Look, the elephant will reach, again, the elephant will be faster than the feather because of a resistance. Why is that? The thing is, the effect of air resistance on the feather is larger than the effect on the elephant. And so the elephant will reach the ground faster. Okay? Now, the reason after this thing is what? I will explain now an example to show this. Now, what if I released an object from a height, I don't know how much, from a height from the ground, and let's say that the mass of this object is 10 kilograms. Now, at the point of release, u is 0. The initial speed is 0. Now, after knowing this, we know that the only one weight that is affecting the object is its weight downward, which is 10 times 9.8, which gives 98 newtons. This is the weight of the object. Now, the speed is 0, there is no air resistance. So the only one thing that is affecting the object is the weight. So what will happen next? Now, I have to ask you a question and you have to answer it, and I will wait for 2 or 3 seconds. Just say yes or no. Do we have acceleration now? So, if your answer is no, this is incorrect, because we have a force, and if we have a force, we have acceleration. What is this acceleration? It is the 9.8, the one that we talked about, the gravitational field strength. In any ways, there is acceleration, which means the object will start moving. If there's no acceleration and the object is at rest, it will remain at rest. So the acceleration here is the same of g, which is 9.8 Newton per kilograms or meter per second. I will keep switching between these units to keep both of them in your mind. Now, the object starts moving, and let's say that the speed now is something. What are the forces that are affecting the object now? Of course, there is weight, which is 98 newtons, which will not change, of course. But because we have some speed, there is some air resistance, which is always in the opposite direction of movement. And let's give some number for the air resistance. Let's make it 28 newtons. So what? What is the acceleration now? As you know, F equals F over m, but of course you know that this F is the resultant force. We will talk about the resultant force after a while, but I think you know this. If we have two forces in opposite directions, you have to subtract. So it's 98 minus 28 divided by the mass, which is 10. This gives 7 Newton per kilograms. Okay, there's a very important thing here. The acceleration is reducing. The acceleration is reducing. We have a decreasing acceleration here. Because of what? Because of the air resistance. But the acceleration itself is still positive, so the speed will increase. But the rate of this increase is decreasing. The acceleration itself is decreasing, but the speed itself is increasing. So the speed will increase more. So if the speed is increasing more, of course, we have the weight still 98 newtons, which means that the air resistance will increase more than this, and let's give it 48 newtons, which means that the acceleration now is 98 minus 48 divided by 10, which gives 5 Newton per kilograms. Look. While the increase of the speed, the air resistance is increasing. As a result, the acceleration is decreasing because the resultant force is reducing. It was 98, now it is 70, now it is 50. So increasing air resistance because of the increase of the speed will reduce the resultant force, which reducing the acceleration, but it is positive acceleration, so the speed will keep increasing. But until what? The thing is, you will reach a point at a certain speed where if the weight is 98 newtons, the air resistance will be also 98 newtons. So the air resistance will keep increasing to reach an amount equals to the air resistance. This means that the acceleration now is 98 minus 98 divided by 10, which gives 0. Don't forget that this object is still in movement, but at this point the acceleration is 0, which means the speed will not change. As a result, the object will keep moving in the same exact speed. Let's give it a value. Let's say that the speed here is 50 meters per second. So the object will keep moving with the same 50 meters per second because the 98 of the weight is equated by the 98 newtons of air resistance. And if nothing changed, this will be the case until the object hits the ground, and that's it. Now, there is a term here, a new term that you have to understand, which is what? It is called terminal velocity. Terminal velocity, which what? It is the constant velocity that the falling object has when the weight and air resistance are equal. Again, the terminal velocity is the constant velocity that the falling object has if the weight and air resistance are equal. So it is a constant velocity. This is called terminal velocity. Okay, so this is a falling object, and I said if nothing changed, the case will stay the same. So what about the skydivers? Of course, 50 meters per second is a huge speed, and if this skydiver reached and hit the ground with this speed, he will die. So the skydivers always use a parachute to try to deal with this speed. How is that? Now, I will again use the same example, but I will continue it. Let's say that my object, after reaching the terminal velocity 50 meters per second, okay, and 98 newtons of weight opposed by 98 newtons of air resistance. This is the case here. Now let's say that this object has a parachute and the object opens the parachute. This is the parachute. So what? The thing is, the weight of the object still 98, but now after opening the parachute, we are increasing the surface area, which is the second thing that the air resistance depends on. So we reached a 98 newtons without the parachute of air resistance. After opening the parachute, the air resistance will be higher. And let's say that it's now 128 newtons. Don't forget that the object is still moving downwards. So what? The thing is, if I want to calculate the acceleration, we are going downwards. So 98 minus 128 divided by 10. So this gives negative 3 meters per second squared. We have deceleration now, which means that the speed will reduce. Instead of being 50 meters per second, it will be something else. Let's say it's now 40 meters per second. Okay? Then, because of the reduction of the speed, the air resistance will decrease too. So it's a loop. Okay? So now, and this is the parachute, okay? Because of the reduction of the speed, okay, the weight still 98, but now the air resistance, let's say it is now 108 newtons. which means that the acceleration will be 98 minus 108 over 10. This gives negative 1 meters per second squared. So still deceleration, and so the speed will reach, for example, let's say 20 meters per second. So the parachute increased the air resistance, which means we have deceleration, which reduces the speed. And because of the reduction of this speed, the air resistance will reduce. So then you reach a point again that this is the object with the parachute. You will reach a point that the 98 newtons of weight and the air resistance return back to 98 newtons because of the reduction of the speed, as I said. So at this case, the acceleration again is 0 at a lower speed than before. We started with 50, if you remember, and now let's say it is 8 meters per second. This speed, okay, the skydiver can maintain, and so after reaching the ground, he can survive. The thing is what? The loop here is the increase in speed increases the air resistance. The decrease in speed decreasing the air resistance. Now, we can represent this by a speed time graph. And here it is. This is the speed time graph for the case that I explained. Now, to start with, you can see a very straight line here at the beginning of the journey, because we said at the point of releasing there is nothing more than the weight, and so the only one acceleration is 9.8. The only one force is the weight that is affecting the object. So we have the 9.8 meter per second squared acceleration. But after the increase of speed, the air resistance is increasing, so the acceleration reduced. And so we have this curve that we talked about before. This is called decreasing acceleration. The curve is down. Now, this decrease in acceleration will reach to a point that the acceleration is 0, and so the speed will stay constant. We call this terminal velocity. Then the object will open the parachute, so the air resistance will increase, and we have a deceleration case here. So there is a drop of the speed, as I said, to reach again to acceleration equals to 0. This is a second terminal velocity, but this is a terminal velocity with a lower speed. Let's say it's 8 meters per second, until the man reaches the ground at a certain point. So this is a resistance. Now, you can talk about the same exact thing for liquids. Of course, we don't have parachute for liquids, but it's the same exact idea.